Good afternoon, everyone. This is Mr. Onofrio. I hope you're having a great Thursday so far. Today, we are going to use our trigonometric ratios to solve real-world problems. All of our lessons in the past have been focused on using them in abstract scenarios, just given kind of a plain, boring triangle and using them from there. Today, we're going to take trig into the real world and see some of the various uses it has. Oh, let's go ahead and let's get started. Our first slide for today is going to be the slide that reads trigonometry in the real world. There are two major ways trigonometry appears in a real world scenario. The first way is through angles of elevation. An angle of elevation is the angle that an elevated line of sight makes with a horizontal line. When you hear that word elevated, I want you to think you're looking up. Elevated tells you up. So if we were looking at that in a diagram, here's your little person. Here's where they would normally look, this kind of dashed line here. That's their normal line of sight. The angle of elevation is the angle formed when they look up at something. This would be the angle of elevation. And the other way we can see it turn up is an angle of depression. An angle of depression is the angle that a downward, cross off that end there, the angle that a downward line of sight makes with a horizontal line. Downward again, meaning looking down. What this would look like on a diagram. So again, you have your little person. This is where they would normally be looking. This is them looking down. Our angle of depression would be right here, angle of depression. Now, there is a super common misconception with these. A lot of people will draw an angle of depression, something kind of like this. The person is looking straight down, and this is their other line. This is not an angle of depression. This is no good. Think of an angle of depression as from where you look normally, and you just decide to look down. Okay. Go ahead and take a second to finish writing and drawing. I would recommend drawing the diagrams. You can pause the video here. Okay, let's move on to our next slide. Y'all already know Mr. Onofrio loves his step-by-step processes. So the next slide we're going to look at is solving a trig word problem. Step number one is one of your most important steps. If you mess up step number one, the rest of the problem is going to be pretty difficult. Our first step is going to be to draw a diagram and label it. To draw and label a diagram. This step sets you up for success by making sure you have all your parts in the correct location and making sure you really know where everything is. It's a great way to take your picture or to take your idea and turn it into a picture. Step number two, you're going to take a look at the parts you're given, and you're going to decide whether you're going to use sine, cosine, or tangent. As a hint, always look to see if you have a hypotenuse. For those who need a review, you should all have a handout that has all of your main trig functions on it. So please be sure to get that out if you need to. Step number three, you're going to set up your equation. This will be sine equals, cosine equals, tan equals, whatever ratio you choose, that's what you're going to use. And then finally, step number 4, you're going to solve for the missing variable. Okay. We are going to go ahead and we are going to work a couple examples now. Go ahead and take a second and pause the video if you need to finish writing stuff down. All right, let's look at our first example for today. We are going to be looking at problem number 21 on your angle of elevation sheet. Problem number 21. We are told Jack is at the zoo looking up at a monkey sitting on top of a pole. If Jack is standing 24 feet from the foot of the pole and the angle of elevation is 23 degrees, we need to find the height of the pole. So first things first, let's draw our diagram. Mr. Onofrio is no artist, so you all don't have to be either. Here's Jack. Here's our pole. And here's our little monkey sitting on top of the pole. We are told that Jack is standing 24 feet from the foot of the pole. 24 feet. We are also told that our angle of elevation is 23 degrees. So Jack is looking up 23 degrees. Our goal is to find the height of the pole, or x. Notice that if we just take this piece, we can redraw our triangle. We can redraw it as a right triangle. Our angle is 23. One of our legs is 24, and the other one is x. Okay. So at this point, we need to choose which trig ratio to use. Notice that there is no hypotenuse. Since there's no hypotenuse, we are going to use tangent. If we're writing down our parts, we know our angle is 23 degrees. Tangent, if you look at your formula sheet, tangent uses the opposite side and the adjacent side. Our opposite side is across from the angle. So our opposite side would be x. Our adjacent side would be 24. Now we can set up our equation. Tangent of your angle equals opposite over adjacent. Meaning tangent of 23 is equal to my opposite side x over 24. To solve our problem, we are going to try, since we have a number on the bottom, we are going to multiply both sides by that number times 24. And our answer is going to be x equals 24 times tangent 23. Just like last week, you're going to get those handy dandy calculators out. You're going to plug this in. 24 times tangent 23. Plug that all in. You're going to get x equals 10.18. And then we look, we're finding height, and the other unit we're given is feet. So 10.18 feet. Box it up and you're done. Problem number 28 is for you to work independently. That is for you to work on your own. At this point, take a second, pause the video if you need to, grab a picture. All right, let's move on to our next problem. Looking at problem number 29. Problem number 29. We are told Caitlin's mom is standing at the bottom of a water slide, waiting for Caitlin to come down. If the top of the slide is 40 feet from the ground and the slide itself is 48 feet long, what is the angle of elevation from Caitlin's mom to Caitlin? We are looking for the angle of elevation. So just like before, let's go ahead and let's draw our diagram. We have little Caitlin up at the top of the slide. And then at the bottom of the slide, we have Caitlin's mom. We are looking for the angle of elevation as Caitlin looks up. So from Caitlin's mom to Caitlin, what is our angle? The other pieces of information we're given is we are told the top of the slide is 40 feet from the ground. And we know the slide itself is 48 feet long. Okay. Now we have everything we need to try and set up an equation. Notice that this time we have the hypotenuse. That means we need to use sine or cosine. The other side we're given is across from the x. We have the opposite side. And since we have the opposite side, that means we have to use sine. Let's identify our parts. Right now, we don't know our angle. Our angle is x. Our opposite side across from the x is 40. And our hypotenuse for sine is 48. We can set up our formula. Sine of my angle equals opposite over hypotenuse. Let's plug in our blanks. Sine of the angle is x, sine of x equals 40 over 48. Our x is inside the sine, so to get it out of there, we can use sine to the -1. We can rewrite our equation as x equals sine to the -1 of 40 over 48. At this point, take your calculator and let's plug it in. Second, sine 40 divided by 48. That'll give you x equals 56.44. We're looking for our angle, so it would be degrees, 56.44 degrees. Okay. Notice that I've left problem 30 alone for you. This is for you to work independently. If you need to take a picture of problem 29, please take this time to grab a quick pic. You can pause the video here. Okay, Let's go ahead and let's look at our next example. The next two examples are going to be talking about angles of depression. Looking at number 31, the angle of depression from a helicopter to a landing pad is 37 degrees. If the helicopter is 1,250 feet from the ground, what is the horizontal distance to the landing pad? Let's draw our diagram. We've got our little helicopter, and then our landing pad. First thing we're told is we have an angle of depression. So let's draw that on there. There's our normal line of sight. There's our angle dropping down, making a nice little triangle. Our angle here is 37 degrees. And we are told the helicopter is 1,250 feet from the ground. Here's kind of the little catch. Our triangle looks a little different than what we might expect. Our 1,250 is going to go right here. We're looking for our horizontal distance. Okay, step one done. We've got our diagram drawn. Now, let's try and figure out which trig ratio to use. We are given no hypotenuse. What trig ratio do you think that would be? Since we have no hypotenuse, we are going to use tangent. Let's set up our problem. We know our angle is 37 degrees. Our opposite side across the diagram is 1,250, and our adjacent side is x. We can set up our equation. Tangent of the angle equals opposite over adjacent. Plugging in the blanks, we would get tan of 37 equals 1,250 over x. Notice our x is on the bottom this time. If you remember last week, the way we handled that is we'd take our two chunks and we'd flip them around. We'd get x equals 1,250 over tangent 37. At this point, let's plug into our calculator. 1,250 divided by tangent 37 equals 1,658.80. We're measuring distance, 0.80 feet. There's your answer. Problem number 32 is for you to work independently. Go ahead and you can pause the video if you need to keep writing. Okay, let's move on to our final example for today. For our last example, we're going to be working problem number 33. While on a hot air balloon ride over Washington, D.C., Xavier spots the White House below. The horizontal distance is 1,478 feet, and the hot air balloon is 2,109 feet from the ground. We are looking for the angle of depression from Xavier to the White House. Okay, First things first, let's draw our diagram. We got our little balloon. Not bad if I say so myself. We've got our White House. Looks just like a normal house. We know from our problem, we're looking for an angle of depression. So let's draw that on there right now. There's our little angle of depression. And since that's what we're looking for, we can label it X. Let's look at our two pieces of information. We are told the horizontal distance from the White House to the hot air balloon is 1,478 feet. So we can label our top chunk 1,478 feet horizontally. And then we know the balloon itself is 2,109 feet. Okay, we have our diagram. Now, let's start talking about how we could set up our equation. We again are given no hypotenuse. Since we have no hypotenuse, we are going to use tangent. Doing our little setup, we know our angle is X. Our opposite side is 2,109 across the diagram. And my adjacent side is 1,478 feet. Let's set up our equation. Tangent of my angle equals opposite over adjacent. Plugging in the blanks, tangent of X equals opposite is 2,109. And then adjacent is 1,478. All right. We have a tan. Our X is inside the tangent. So what we need to do is we're going to use tan to the -1. Just like we did with sine to the -1 two examples ago. This lets us rewrite our equation as X equals tan to the -1, 2,109 divided by 1,478. I'm sure you already know what's coming up now. Let's go to that handy dandy calculator. Second, tan 2,109 divided by 1,478. Your parentheses and hit equal. It's going to spit out X equals 54.97 degrees. 54.97 degrees. And we know it's degrees because we're looking for an angle of depression. Okay. So at this point, if you need to pause the video to finish writing, you can go ahead and do that. For the rest of class today, for full points, you can work on the problems that we did not complete. So problems 34, 32, 30, and 28. You can also begin to work on your 5 Dreambox lessons. Once you are done with your assignment, you can submit a picture on Canvas, or you can put your paper on my back desk and I will grade it when I get back. Thank you so much, and I hope you have a wonderful rest of your day.